Assalamualaikum everyone, welcome back. So we're going to continue our lecture on grinding 2. Without further ado, let us continue. There are 3 types of grain action in grinding. Number 1 is cutting, and then second is plowing, and the third one is rubbing. In the cutting, the abrasive grit will project far enough into the surface and produce a chip, which means material is removed. And then second is plowing. The grit is project into the wall, but it is not far enough to cut the surface. Therefore, there is no material is removed, but there is some deformation and energy also is consumed. And the third one is rubbing, where the grit contact the surface, but it's only rubbing and cause a friction on the surface, which consume the energy, but there will be no material removal there. Now, let us look into the grain action in grinding for better understanding. If you can see from the picture here, for the cutting process, the abrasive will go into the workpiece and there will be chip coming out from the workpiece, meaning that there is material removal process happen during the process, okay, during the grinding process. So this one is usually in the process of you want to remove the rust on the surface of the work material, or you want to fine tune to get the close tolerance of the workpiece. Then this process take action. Another one is plowing. So plowing is when we want, if you can see, the abrasive touch the workpiece, but there is no material removal process take place. Okay, so it doesn't mean that the process is irrelevant. Okay, so this one is important when you want to create a scratches on the surface of the workpiece. Okay, so that's the plowing process. And the third one is rubbing process. If you can see here, the abrasive barely touching the workpiece. Okay, so this one is rubbing process. So rubbing process usually happen when you want to get a very fine surface roughness. Okay, so that there will be a small scratches on the surface until you get like a mirror like surface. So that's happen in the rubbing process. Grinding is known as a very high temperature and high friction process where most of the energy during the process will remain on the work surface. So this one will result in a very high surface temperature on the surface of the workpiece. Okay, so due to that, there'll be damaging effect on the surface on certain processes. Okay, so the first one will be the surface burn and crack. So it can also cause metallurgical damage immediately beneath the surface. It can also be softening of work surface if heat treated. So because of the heat that happen on the surface of the workpiece is already high, so then there will be softening effect on the work surface. And the last one will be the residual stress in the work surface. Here are some examples of the defect caused by the high temperature. Okay, the first one showing the burn surface. If you can see here, here is the burning surface caused by the high temperature during the grinding process. And here is the white layer. So this one is it changed the metallurgical surface of metallurgical of the workpiece during the process. If you can see, this is the white layer, and then it followed by the dark burn on this area, and this is the original microstructure, supposed to be like this one. Okay, so the third one is, this one is the residual stress during the process. When the temperature is high, so the residual will start to increase again before it goes down. Okay, so what will be the effect of residual high residual stress in the workpiece? First, it can reduce the lifespan of the workpiece. by reducing the fatigue life of the workpiece, and it also can cause crack on the surface of the workpiece. So we don't want residual stress to be very high. So how can we reduce the grinding temperature? There are several methods. Okay, the first one, you can um, control the parameters by decreasing the feed or the depth of cut of the grinding process. You can also reduce the wheel speed, and you can also reduce active grit per square inch in the grinding wheel. So meaning that the grit on the area is less compared to the very dense one. Okay, and then you can increase the work speed, and lastly you can use grinding fluid in order to reduce the temperature. Now let's see the causes of a wheel wear. There are three causes of wheel wear. The first one is grain fracture. So what is grain fracture? This grain fracture is when a portion of the grain break off, but the rest of the grain will still remain bonded to the wheel. Okay, so let's say this is the grain and attached to the wheel. Okay, so what happened is some portion of the grain will break off, and then will come out with the new sharp edges. Okay, so this condition is called friability, which is the tendency of the grain to fracture. Okay, so this condition is favorable to us. Why? Because when this happen, it will create new sharp edges, like it is a self reshuffling of the wheel. Okay, now let's see the second cause of wheel wear. The second causes of wheel wear is atrocious wear. So what is atrocious wear? Instead of the edges of the abrasive become sharp edges like the grain fracture, it become rounded. Okay, so it become round. So that's what we call as atrocious wear. So this one, it will dull the individual grain, so it will result in flat spot and rounded edges. So what happen is when it is atrocious wear, you cannot use it anymore for the process of grinding, because it's not going to do anything on the surface of the workpiece. And the third one is bone fracture. So there'll be a level where automatically after the atrocious wear happen, and then there is a force on the grain. What will happen is this grain will be pulled out from the bone. Okay, so leaving this area empty. So this is the third the third causes of the wheel wear. This graph shows the typical wear curve in the grinding. So instead of plotted in terms of time like the lathe machining, it is plot again volume of work material removed. So what happened is it will start from increasing, and then it will gradually increase before it can become a wheel wear, the maximum wheel wear happen. So this graph can show the grinding ratio of the wheel wear. So this one is calculated if you can see the graph previously. So there's a slope here. So what happened is we can calculate it using this equation. So VW over VG, which is VW is the volume of work material removed, okay, and VG is the corresponding volume of the grinding wheel one. When the wheel is already wear, what we have to do is we can do the dressing on the wheel, or resharpening the wheel. Okay, so how do you perform the dressing of the wheel? What you have to do is just you put the rotating disc or abrasive stick or another grinding wheel together, again the wheels. Okay, so this is the abrasive stick and this is the grinding wheel that is rotating. So and then let it rotate, and what will happen will be it will break off the dull grit and expose the new sharp grain, and it can also remove the chip that clog in between the wheel. Okay, so this one is only performed when the wheel is in the third region of wear curve. Another method is by truing the wheel. Okay, so although you might already perform the resharpening or the dressing of the wheel, sometimes the dressing of the or sharpening does not guarantee the shape of the wheel, meaning that the roundness of the wheel might already change. Okay, so what happen is we can use the diamond pointed tool and fed slowly and precisely across the wheel as it rotates. So this one is very light in depth, is around 0.025 mm or less again the wheel. Okay, so this one is not only sharpening the wheel, but it's also restore the true disc shape. Okay, so if you can see from the in the picture, this is the diamond single point tool. Okay, so what happened is the tool is placed here. Okay, and then we let the wheel to rotate slowly, and what happened is it will create the uh, like new edges. It will scratch on the abrasive and make it into rounder wheel. Okay, and it will also expose new sharp edges to the wheel. Here is two links for you to look into. One is sharpening of the wheel and another one is throwing the wheel. You can go to the link and look into the video for better understanding of the process. Now that's the end of part 2 of grinding. We'll continue with part 3.